We often imagine entropy as the villain, the great unmaker, the ghost that haunts order, the final whisper in the collapse of all things. But this is only half the story. Entropy doesn't simply unravel, it enables. It's easy to see entropy as a destroyer. It is, after all, why castles crumble, why stars dim, why civilizations leave behind dust. But entropy is also a sculptor. It doesn't just erase structure. It provides the conditions that make structure possible in the first place. How? Because entropy demands flow. And flow of energy, of heat, of information, is the source of emergence. A world without entropy would be still, frozen, sterile. Everything would be in perfect balance, unmoving, inert. There would be no friction, but also no fire, no decay, but no breath. What entropy does is create the difference between one place and another, between hot and cold, high and low, concentrated and diffuse. And where there is difference, there is potential. It is precisely because the universe is uneven, because it is still becoming, that anything becomes at all. We do not live in a universe that is settled. We live in a universe that is still in motion. Sun burns because it is out of balance. It radiates energy because it must. Its core is a furnace of nuclear fusion. And the difference between that core and the cold of space creates the flow of light. Photons racing outward, carrying heat, driving winds, awakening chlorophyll. It takes just over 8 minutes for that light to reach Earth, and when it does, it collides with an entire planet out of equilibrium. Some of that light warms ocean currents. Some drives the weather, evaporating water that becomes storms. Some is caught by leaves used to split molecules of water and build sugars. Some becomes food. Some becomes thought. This imbalance, the energy gradient between our star and the void, is what powers everything. Entropy increases when energy flows, but that increase allows patterns to emerge along the way. Take a thunderstorm. It forms when warm air near the ground rises into cooler layers above. The resulting instability releases heat, forms clouds, sends down rain. From imbalance comes structure. Or consider plate tectonics. The Earth's crust breaks, slides, and rises not out of spite, but out of heat trapped inside a slowly cooling planet. From imbalance, continents form. Mountains rise. Minerals mix. Even the deep-sea vents, home to alien-like ecosystems, exist because of heat leaking from the Earth's core into a freezing ocean. Where heat meets cold, life begins. Everywhere you look, entropy's uneven march doesn't stifle change. It drives it. The cosmos is not boring because it runs down. It's interesting because it's not yet done running. In 1977, Belgian chemist Ilya Prigogine won the Nobel Prize for describing one of the most beautiful paradoxes in science. That in systems far from equilibrium, order can emerge spontaneously but only because entropy is increasing overall. He called these phenomena dissipative structures. The idea is deceptively simple and radically powerful. Some of the most striking patterns in nature arise not in spite of entropy, but because of it. Take the simple act of boiling water. Heat the bottom of a pot. Soon you'll see swirling cells of motion, hexagonal convection rolls, endlessly forming and collapsing. These aren't random. They are structured responses to energy flow. Or look at a hurricane, fierce, vast, exquisitely organized. It's a spiral of warm air rising and spinning, formed entirely from a thermal imbalance between ocean and atmosphere. It doesn't defy entropy. It's enabled by it by taking disorganized heat from the sea and turning it into motion, wind, cloud, and rain. Hurricanes, convection cells, lightning, turbulence, these are entropy's artworks. They're brief, they're local, and they're not permanent, but they are real. Now take one more step. A living cell is a dissipative structure too. It gathers energy, expends it, stays alive for a while only, because it remains out of equilibrium. It does this by burning fuel, by breaking molecules, by releasing heat into its surroundings. And in doing so, it maintains its internal order for just a bit longer. Living things in this view are entropy surfers riding the crest of cosmic imbalance. Borrowing time from thermodynamics, spending it on metabolism, movement, memory. They are not exceptions to the second law. They are its most elegant consequence. Life feels like resistance. It grows upward when gravity pulls down. It builds structure where randomness waits. It memorizes, metabolizes, replicates. To the untrained eye, life seems like entropy's opposite. But to the universe, it is something far more interesting. Life is entropy's accomplice. A living cell is not a closed system. It is porous, responsive, inhale, exhale, input, output. It takes in ordered energy, sunlight, sugars, oxygen, and uses it to maintain itself, to grow, to adapt. And in doing so, it releases heat, waste, and disorder into its surroundings. Every act of life, every thought, every heartbeat, every breath is thermodynamically expensive. It buys a moment of order, at the cost of greater entropy somewhere else. This is not failure. This is how life works. What sets living things apart is not that they reduce entropy, but that they channel it locally, decreasing disorder while globally obeying the law. Life is not the antithesis of the second law. It is one of its most dazzling expressions. And life doesn't just respond to entropy, it learns to exploit it. Bacteria position themselves along thermal gradients. Plants orient their leaves toward the sun's most efficient angle. Animals consume energy-rich molecules to do the improbable: heal, hunt, remember, run. Even evolution, the slow sculpting of traits over eons, can be seen as a kind of entropic search. A billion random changes, most discarded, a few retained. Patterns emerge, forms stabilize, and adaptations bloom. None of this violates entropy. It all flows from it. Entropy is not the end of life. It is its background rhythm, the drumbeat beneath biology's fragile choreography. And the more we study living systems, the more we see this elegant trade. Order within, paid for by disorder without. To live is to be out of balance, and to stay alive is to manage that imbalance just a little longer. Now lift your eyes beyond the cellular, beyond the organic. Look up at the stars, each one a beacon of imbalance, a nuclear engine fighting collapse, a monument to thermodynamic difference. Stars are not quiet, they rage. But in that raging, they give the cosmos its canvas. From the birth of stars come solar systems. From their deaths, the heavy elements, carbon, oxygen, iron, are scattered into space. Everything you are was once forged in that violent entropy. But it doesn't stop with elements. From the chaos of stellar birth clouds emerge planetary orbits. From planetary surfaces emerge climates. From climates, oceans, atmospheres, weather, and eventually, if conditions permit, consciousness. Not because entropy paused, but because it flowed. From starlight to sugar to synapse, entropy moves, and as it moves, it creates spaces where thought can form. Minds, too, are entropic. They metabolize fuel, they burn glucose, they generate heat. To think is to spend energy, to sort, to store, to reflect. And just like memory, thought is directional. Your ideas travel from known to unknown. From order to possibility. Brains do not escape entropy. They ride its wave, moment by moment. And they do something truly astonishing. They model entropy. They imagine time. They forecast futures. A brain is not merely reacting, it is predicting. It is trying to find patterns in the noise. From cells to civilizations. From hydrogen atoms to humans asking what entropy means. The very act of questioning this law is made possible by the temporary, structured complexity that this law has allowed. So when we say entropy always wins, yes, it does. But what a game it plays along the way. Stars are temporary. Life is temporary. Even thought is a flicker, but none of it is waste, because each pattern, each process, each pulse of order that briefly slows the flood is a masterpiece made possible by the river's flow. Entropy is not a flat field. It is a tilted stage. And from that slope rise galaxies, hurricanes, and minds that wonder why.